All right, today is an exciting day because I'm going to be teaching you about that thing that you've just been dying to learn about for weeks now. And that thing is called logarithms. Okay. And we've actually sort of done logarithms before because we've solved exponential equations in the past. So I might say 3 to the 2x is equal to 4. And you all know that your next step is 2x is equal to 4, which means x is equal to 2. What I haven't shown you, what I've refrained from showing you, is the step that allows you to do this, the step that undoes an exponential function is a logarithm. So what I'm really doing here is I'm taking the log base 3 of both sides. And what happens with a log base 3 and a 3 to the is they cancel each other out. And the same thing would happen if I did 3 to the log base 3 of 10. Those two operations would cancel each other out and I'd get 10. Okay, so the logarithm, what you should know is it is the inverse of an exponent. It is to exponents what subtraction is to addition or division is to multiplication. And it's just another operation. It's just one that you haven't seen before. So it's helpful to know that you can take any logarithmic statement and write it as an exponential statement. So for example, log base 4 of 16 is equal to 2. And the reason that that's true is because I can write the statement as 4 to the second power is equal to 16. So it's this thing is the base, this is the exponent, and this is the answer. And I think you have to just kind of get used to doing a couple of these, and then just the basics of a logarithm makes sense. So I might think of 5 to what power equals 125? Well, that's going to be 3. So log base 5 of 125 is equal to 3. I might think of 7 to what power is equal to 1/7? Well, that's -1. So log base 7 of 1/7 is -1. I could think of log base 6. 6 to what power is equal to 1? Well, that's 0. 2 to what power is equal to 1024? Well, you may not know that off the top of your head, but I do because I'm a nerd like that. So that's 10. And then the couple other things, tricky things about logs is that number one, sometimes you'll see them and they won't have a base. And if they don't have a base, it's implied that the base is 10. Okay. And you'll see there's even a button on your calculator where there's a log with no base. So a lot of times they're just changed into the base of 10. And then another thing that's log related, but it looks a little different, is this ln. Okay. ln stands for natural log. And I think it comes from Latin where they probably was like logo naturale or something. So that's why we get ln. But ln stands for natural log. And what you can think of it as is it's a log with a base of e. Okay, so ln of e squared would be 2. Now, one thing that may be worth just pointing out here is when you think of, let's think of this function y is equal to e to the x. And notice that it's defined in the top two quadrants. So x can go between negative infinity and infinity. Y only goes from 0 to infinity. So when I look at the inverse function, y is equal to ln of x, remember that they're reflections over the line y equals x, and you can see that. But also remember that the domain in one is the range in the other. So the natural log of x, if I'm thinking of the natural log of x, it's only defined where x is greater than 0. Okay, so you can put a y value that goes between negative infinity and infinity into a natural log function, but you're only going to have an x value that's between 0 and infinity. So there's a couple log properties that I'll go over in the next video that relate to the properties of exponents. But there's one that I'm going to go over now, which is called the change of base formula, that you should know, because in your calculator, you can't actually, or it's hard to find the place where you can put log base 4, but you can always change a log this kind of way. So the log base 4 of x is the same thing as saying log of x divided by the log of 4, which would be the same thing as saying the natural log of x divided by the natural log of 4. Or you would never do this, but just to demonstrate the property, I could pick any number here. So let's say log base 6 of x divided by log base 6 of 4. And that's one way that you can change it so that your calculator can handle the problem that you're given. It's going to take practice with a lot of these things. I want to finish by showing a rule that has to do with logs, but I'm not going to connect it to you. Your job is to figure out why this rule works. But this is kind of a helpful rule to know when you're talking about finance, you're talking about investing. I learned it back when I was working for Fidelity Investments and managing people's retirement accounts, and it was called the rule of 70. And the rule of 70 says, I can figure out how long it'll take an investment to double based on an interest rate if I divide that number by 70. So let's say I have a 7% interest rate, and I want to know how long, let's say I put $1,000 in it, and I want to know how long will it take for that investment to double or become $2,000. Well, I would take 70 divided by 7, and I would get 10 years. Let's say I had some other amount. Let's say 5%. Think in your head, how long would it take for 5% investment to double? Well, 70 divided by 5 is 14, so 14 years. You want to keep going? Let's keep going. Let's say 2%. How long would it take a 2% investment to double? It wouldn't take 50 years, because remember, it's exponential growth. 70 divided by 2 is going to be 35 years. Okay? If I said an investment's going to double in 7 years, what would the interest rate be? We should be able to think that means the interest rate is going to be 10%. So my question is, why? Why does the rule of 70 work? Why does the rule of 70? It's not exactly right, but it's very close to accurate. And my question is, why does it work? And I want somebody to figure it out. I don't want you to Google it, because if you Google it, you'll be told the answer right away. But I want you to think about it and see if you can, by the end of this week, come up with the reason why the rule of 70 works.